Hello everyone, today I will show you how to build up the gradient descent function from the scratch and apply it with the linear regression for multiple variables. I will build up the code from the scratch so that you can understand every part of it. So, multivariable linear regression using gradient descent. This is how my data is look like. So it has 4 columns. The first 3 columns are independent variables and the last column is dependent variable. The data link is given in the description below. So what is the process of doing linear regression using gradient descent? The first step is, for example, you have n number of variables. So you have to set up the hypothesis hx, which is a function of theta and x. So theta naught x naught plus theta 1 x1 theta 2 x2. In our case we have 3x, so we will go up to the next one like theta 3 and x3. Okay, so this x naught is basically always 1 because we're thinking this is a simple linear regression like a straight line. So the first one is basically theta naught, which is a constant. So if you look carefully, this is the main hypothesis. So for the sake of our simplicity for the algorithm, we have to add an x naught here and set it as 1. So first thing first, we import the data first and we will see this matrix, and this matrix has x naught here where I said x naught is always equal to 1, and we will initialize the variables, theta variables, maybe 0 or 1. So first the hypothesis, we will set up the hypothesis and we will initialize the parameters. Then we have to find out the cost function. This is the generic formula for the cost function, 1 by 2m integration of I equal to 1 to m, that hypothesis, minus y, which is our ground truth. So this m is basically the total number of training samples. Now for the gradient descent, you have to update this theta from here, like using this formula, theta j equals to theta j minus alpha times partial derivation of this cost function. So this theta j is the new theta j and this theta j is the old one. So this has to be repeated in a loop until you get the best result or you get a stopping point using number of iterations. So the cost function, if you do the partial derivation, it simplifies into this function. So make sure whenever you update the theta j, the first theta naught actually always having x naught equals to 1. But for other cases, you don't have that x naught, theta naught, so it will be theta 1, theta 2 or theta 3. You have to put xj I here. So I is basically, the number of the iteration through the number of samples, and j is basically the iteration through the thetas here. So we have 4 thetas because we have 3 variables. So this j is maximum, j equal to 4. So this is basically the formula. Now we will implement this formula using Python. The first thing is we have to import necessary libraries. So I will use import numpy as np. From numpy I will import gen from text because I have a CSV file for the data and I have to import this gen from text to read the CSV file. Press Ctrl Enter to run this, and then next step is to import the data. So I'll use, for example, data equals to gen from text. My file name is d3.csv, and then delimiter. So now I have to separate the x variables and the y variables. So the capital X I will set, so I will select the all rows but from 0 to 3, that means first 3 columns, and y will be equals to all rows but the last column. Now I will check out the data, how is it sliced correctly. Print x, but I will print a portion of it, so I will print from 0 to 10, and then Ctrl Enter. So the x variable is correctly segregated from the main data. Now let's look at the y variable here. Put y here. I'm sorry. For y variable I will print from 0 to 10 just. Okay, we can see the data is correctly loaded. Now I will set up the function to determine the linear regression using gradient descent. So I will define a function which is linear regression using gradient descent, and I will put the values here: x, y, alpha, and number of epochs, which is basically number of iterations. So this function is divided into 2 parts. The first section is the linear regression, and the second section will be the gradient descent function, so that we can get the theta and the costs. So m shape of 0, which is basically number of samples. Now one important thing I told here is basically the first x naught you have to set as 1. So basically if you look here, we have x1, x2, x3. So for these we will get maybe theta 1, theta 2, and theta 3, but we have to add another column here for theta naught. Basically all of them equals to 1. So we have our data here, original data, but we have to add this column here. For this reason I will create one numpy array named ones, and I will set it the dimension of m is 1. Basically this one I will concatenate with the x variables. How you will do it? So np dot concatenate, and then ones x is equal to 1, so that it will add in the column wise. So the first portion will be the ones in the column wise, and the second part is basically all the data in the x variable. So this is our new x with x naughts equals to 1. Now we will get the n here. N is basically x dot shape 1. So we have n equals to 4 here. That means number of thetas, basically n here. So number of feature basically 3, but we will get n equals to 4 because we have already added a column with ones in the beginning. Next, we will set up we will initialize the theta variables. So I'll set np.ones, and with the dimension of n here, n is equals to 4 because theta naught, theta 1, theta 2 and theta 3. So this is parameter initialization. And after parameter initialization, so what we have to do basically, so we have to make this hypothesis. So if you look carefully here, this is basically a dot product of x and theta. So hx is basically a dot product of x and theta. So we will do it like this. So we will say h is the hypothesis function, and we will set np dot. So which two matrix will be dot product, x and theta. So this one is our compute the hypothesis. So this part is done with the linear regression. With the same function, within the same function, we will now build up the gradient descent algorithm. So in this case, we will store the cost in a variable, in an array, so that we can determine finally how the cost function is getting lower. Ideally it should goes to 0, but maybe we will not get 0. As close as 0 we will try to get. So the cost function, the cost will be stored in here. So the number of iteration, number of epoch. So number of cost will be equal to the number of epoch. That's why I initialize an array having ones, whereas I can store the cost. Now we have to run a loop until we get the cost to be the minimum. So the first loop is from 0 to number of epoch. Now we have to find out the theta naught and all others theta. That means theta 1, theta 2 and theta 3. But if you remember, the first theta, for the first theta j, theta naught, basically we have to set x naught is equal to 1. That means this term will be eliminated. So we only left with this function. That means h naught of x minus y, which is the ground truth, and h naught x is the hypothesis. That is why theta 0 will be updated in this way. Theta 0. Now theta 0 minus, you have to multiply with the alpha, which is the learning rate here, and then divided by x naught shape of 0, shape 0, and then you have to multiply it with sum of h minus y. So you see here the sum. So alpha times 1 by m. M is basically the dimension, number of rows. That means the number of training samples. So hx minus y, we have to loop from I equal to 1 to m. So this is our m, alpha divided by m now. This part is basically for the theta naught. Now for the theta j, I mean from theta 1, 2 and 3, we have to set up another for loop. In range. Now we have already got the theta naught, so we have to start from 1 to n. So in this way we will get theta 1 and finally theta 3. So for this loop, theta j equals to theta j minus alpha for shape 0, and then we have to multiply it with the same function, sum of h minus y, but we have to multiply again with this xj. That means x1, x2 or x3. So we have to do this using this formula x of, so we will take all the rows and jth column. Now after doing this, all the thetas are updated. Now we have to do the hypothesis computation again. H equal to np dot x and then theta. So in this way we will get new hypothesis hx, and that loop will be continued until the n number of epochs, I mean whatever iteration number you set here. Now after every iteration you have to find out the value of cost. We will look into it whether it is decreasing or not. So the cost function is basically 1 by 2. So cost function, if we look here, so this is our cost function, 1 over 2 of m, and this part is basically similar to this inside function, but it has a square here. This is why we will do this. So 1 over m, this is multiplied 1 over 2m, and then sum of np dot, there is a function called np dot squares, np dot square, now h minus y, then you are done with your cost function. So basically compute your cost, and what you are gonna return from this part, I will return the cost and theta, because theta is our final target and we will see the cost function. Now our function is built up here, so press Ctrl Enter to run that. Something is wrong. So okay, I forgot to put here equals to. So you have to update the theta j, new one is equal to theta j old minus this function. Now press Ctrl Enter and you'll see no error. It should be fine. Now our target is to calculate the theta and cost for our data. Now say cost theta equals to linear regression of the function. What are the inputs we have? We have x, we have y. Now we have x, y, and then we have alpha and epoch. So say alpha we set 0.1, and then number of epochs say 2000. Now if you want to print the theta, So j is not defined here. What's wrong? Okay, let's see. What do j is not defined? Okay, so j is not defined here. Oh, I got that. So this j is a capital J. I put my mistake. So I have to make it smaller because j is small letter here. Around this section, around this section, and finally I have got my thetas. So theta 0, theta 0, theta 1, 2, and theta 3. So we have got our thetas. Now if you wanna check with the different learning rate, you can always do and see what is the change. You can put with another one. So basically how you will see that, we will check in the cost function here. So the next step is to plot the cost. So I will use plt cost. I will label the x level is basically epoch or number of iteration, and plt y level is basically cost or loss. plt.show. So we got a nice curve here. Basically our cost is gradually decreasing after every iteration. So we see at the end of 2000 iteration our cost is lowest, but in this portion basically already the cost is low here, so it didn't decrease after 250 that much. So we will print the lowest cost here, print lowest cost equals to so np.mean of cost. So if you see that our lowest cost is basically this one. Now the lowest cost could be anywhere in between this point and this point. Excuse me. The lowest cost could be anywhere in between this point and this point. But what is the cost after end of 2000 iteration? Iterations. So I'll use -1 to see the last one of the cost. So you see the lowest cost is 0.738, and after 2000 iteration it is still 7384. So now we have got our model, we have got our theta variables, thetas. Now maybe you are interested with some of the predictions. So randomly you choose your data and then put in the model to check with the output with these thetas. You want to check with the predictions for some x variables. So I will set up the x predict 1. So basically, say for example you are gonna check with 1 1 1. Now how will do that? So y underscore predict 1 equals to, you have to apply that concatenation function first, so that your x predict, you already remember that, right? You have to add another 1 in the beginning. So either you can do it manually, so I'm adding it here, and then you can apply the dot product here. Basically you have to use the hypothesis and your theta. So you already know your thetas, right? 4 thetas. So it will just be np dot your x predict 1 and then theta, and then I will print y predict. So this is 3.57. Now if you would like to check with some other things, like I'll check with the 204, some random number, then you will see your prediction is 0.24. Now we'll go into the built-in function to check with that whether our function is working properly or not. So to do that, you have to input the linear regression function first. So from sklearn import linear model, and now say our linear model is LM. Linear model is equal to linear underscore linear model, and you have to use dot linear regression, and then you have to feed with your data. So lm dot feed your x variable, right? So your x and then your y. Press Ctrl Enter. Your model is built up already. Now how you want to find out the coefficients, that means theta naught. So print lm dot coefs. So this will give you the coefficients. But if you want to build the intercept, so this is the intercept. Press Ctrl Enter. So the intercept is basically the theta naught, which is here, and your theta 1, theta 2 and theta 3 are here. So 5.31 minus 2.53 and minus 0.26. What did we have here? 5.3 minus 2, which is basically equal here, minus 2, and then 0.53 and 0.26. So 0.53 and 0.26. That's all for today. That's the linear regression using gradient descent algorithm. If you like this video, please press the like button and please subscribe so that I can get more videos for you. Thank you so much for watching. Happy coding.